So now we get into what I call the fun stuff. So this is how to manipulate signals, make things sound the way you want them to sound. And so I listed them and broke them down, all of the effects that you can do to a sound, into 3 different categories: dynamic-based processing, delay-based processing, and computer-based processing. Dynamic-based processing revolves around signals being louder and quieter in terms of a performance. Everybody knows that when a singer sings louder, it sounds different than when they sing quieter. When you play a piano quiet versus loud, it sounds different. So it's being able to manipulate the dynamics and the sound quality during that loudness to soft passage. And everybody, every human, can't be precisely the same every time they hit a drum. Some drum hits will be louder than the other. Some guitar strums will be louder than others, and so on. So part of the whole process of making things sound polished and finished as a recording revolves around dynamic control. Think about this. So let's say you've got 4 pieces in a band and they're playing. You go out to the club tonight and you watch a band play, and you notice that in the verse everybody gets quieter, and then in the chorus everybody gets louder and it gets bigger. It's not only that the drummer's playing more cymbals and it's filling out the spectrum more, it's also that they're playing harder. And if the musicians are well rehearsed and really know each other very well, they ebb and flow in terms of the dynamics. They ebb and flow together. And that keeps the perspective of the blend of the drums and the bass and the keyboards and the guitar all sort of intact as they move from section to section. Then the listener finds that the perspective of each sound element sort of stays intact as it moves along. Compressors can help a lot with that, and dynamic control can help a lot with that in terms of how loud and how quiet the dynamic of each element gets. Delay-based processing is processes where a delay is involved in creating the effect. We all know that when you stand on the edge of the Grand Canyon and you shout, "Hello!" you hear, "Hello, hello, hello," delayed, coming back at you and getting quieter. That's delay, obviously, based upon the fact that sound takes time to travel, bounce off the other side of the Grand Canyon, bounce back to you, and back and forth and back and forth. That's an exaggerated version of what a delay process would be, but you can simulate that in your computer with a plug-in, a simple delay. Let me actually list a few other of the delayed processing effects. So delay is obviously one of those processes, and that's the longest of the delay processes. Before you could perceive a delay as being a delay, a specific repeat of what you heard. 50 milliseconds. That's quite short in regular terms, but in terms of the processing world, it's the longest. Now, if you make the delay shorter and we add it back to itself, we get phasing. So if you take a signal and delay it just slightly and add it back to itself that hasn't been delayed, then you get phasing. Well, that creates a notch in the spectrum where at certain frequencies they'll cancel each other out, and certain spots they'll add to each other. And so you create a distortion in the frequency domain of the sound, and it's a specific sound, especially if the delay changes just slightly. Then the filter or the notch of what you've created, the phasing changes frequencies back and forth. That's called phasing. It's called flanging. Those kinds of effects are built off of shorter delays than just regular delay. So they're about between 1 and 10 milliseconds. 50 milliseconds so you can perceive a delay, 1 and 10 milliseconds or so for phasing and flanging. Even shorter delays create EQs. We discussed what an EQ is, taking a signal, delaying it just slightly and adding it back in different proportions to its non-delayed self can either create a frequency where it diminishes or it adds at those frequencies. So EQs are delayed-based effects, phasing is, flanging is, delays are. Another one that we really haven't discussed very much, but it seems clear that reverb would be delayed-based effects, because if you're in a gymnasium and you clap your hands and you hear the reverb, delaying down, sort of going this whoosh sound that goes away, or you hit a snare drum or a kick drum in a big hall, that's based upon delays bouncing off walls at all different directions, all different times, arriving back at all different phases, all different times, and it's sort of a multitude of thousands upon thousands upon thousands of delays, all different, coming back to you at different times, and then eventually decaying to nothing. So reverb is a delayed bass effect. It wouldn't happen if there wasn't a delay because of the speed of sound, right? If the speed of sound was much faster, we wouldn't be able to hear any of those delays. Delay-based effects are the typical effects that people think of as manipulating sound. EQs, reverbs, delays that regenerate upon themselves, phasing, flanging. The third category is computer-based effects, which people are having much more fun with their laptops now than we used to in the old days because we didn't have a lot of computer processing. But there's things like auto-tune, time correction of drums, right, where you can go into your screen and you can move a drum, nudge it here, nudge it there, and correct time. We couldn't do that when we were on tape very easily. It was very difficult to do. So computer-based effects are sort of the new world of effects that you can do with your computer and with sound. And there's a lot of different things that you can do in the computer that you could never do before, like correct vocals, pitch on vocals. I mean, everyone's heard that. I have this theory that in the future, people are going to look back and go, oh, that was 2015. You know, it's like, oh, that auto-tune effect. Because I remember in the 80s when we used to use the Ultra Harmonizer, which was the newest, coolest effect. We used it on everything because it was so new and so cool and made everything sound modern. Now you listen back and it sounds like 80s. Okay? So remember that these effects kind of put a date stamper on your music if you overuse things. The interesting thing, and I'm not going to go too far into this because this comes more about production, is, you know, when you use effects that are time delay based effects like reverb and those kinds of effects, those things have occurred since the beginning of time. We hear them in our everyday life, and so it tends to make the music sound more classic and not related to one time period. But when you use the newest computing device to generate the newest, coolest effect, that's when you get something that sort of stamps it as, oh, that's the era that was. So when you use effects, it's really wise to think about what your music really represents and whether you want it to sound classic in 10 years or not. Or maybe you don't. It just depends. If it's all about disposability right now, but cool, oh, this is cool, I'm going to use this because it's going to get attention. Or is it about the song and representing it in a way that generations from now they'll listen to it and still understand it and it'll still be meaningful. Like a piano is going to be a piano in 100 years and it's still going to sound like a piano, I hope. Anyway, okay, so let's get back to our effects processing. First, let's start with the first category. This is a huge topic, and unfortunately, I really only get this class to talk about it, so we'll probably not finish it all and get into the next class about it. It's really important stuff. So let's start with dynamic-based processing. Any process that alters the dynamic range of a signal. Compressors fall into that category. Limiters fall into that category. Expanders fall into that category. Gates fall into that category. And this is, as I said, one of my favorite topics because I totally, truly believe that the most important process that you can have in making any musical project sound finished and polished is dynamic-based processing. First thing engineers usually do is go and grab an EQ and start changing it because you understand that from your car dial, you know, your tone on your car. And it's real nice to just add high frequencies and everything sounds more sparkly and more lifelike, add more bass and so on. The fact is that if I was stranded on a desert island and had to make a record, which would be an odd situation, I would absolutely want dynamic processing. That's all I need to make something sound like a finished product. Let's talk about compressors first. Compressors come in two sort of overall categories. There's the feed-forward design and the feedback design. What a compressor really is it's a device that automatically controls volume. The feed-forward device looks at what's coming into the amplifier and controls the output of the amplifier. So it kind of knows how loud the signal's coming in and controls how loud it comes out. The feedback type design basically looks at what's coming out of the amplifier and says, oh, gee, it's getting too loud, we better turn down the input. So it's sort of a little behind the curve. And actually, you could consider a compressor to be called a leveling amplifier. In fact, some of the vintage compressors, like an LA2A, which is a vintage compressor, calls it a leveling amplifier, because what it does is it maintains a consistent level of the signal, not too loud, not too quiet. It sort of limits the dynamic range, and it's an amplifier. An amplifier, you typically think of an amplifier as something that takes something very small volume and makes it loud. This kind of an amplifier takes whatever's coming in and controls how loud and how quiet it gets. So it's really unity gain when it's operating properly and controls the loudness.